Hello guys, in this video I want to describe the movement of the particle which is given by that parametric equation. So as a first step, what should we do? We should find the Cartesian version of that parametric equation. And for that we need to eliminate our parameter t. So first observe that we can write x as sine t and our y as cosine squared t, and since we have the main trigonometric identity, then cosine squared t is equal to 1 minus sine squared t. Or in other words, if I'm going to replace sine t with x, I will obtain a Cartesian equation of my parametric equation, which is y is equal to 1 minus x squared. And then y is minus x squared is going to be just regular parabola x squared, but which is reflected along x-axis and shifted by 1 upward. So in other words, I'm going to have the corresponding graph if I'm going to plug in 3 points to sketch it, which are x equal to 0, x equal to 1, and x equal to -1. So in other words, we have the following Cartesian equation. So for our next step, what do we want to do? We want to take our parametric equation and analyze our parametric equation corresponding to t. So as a first step, let's sketch the function x is equal to sine t, and by sketching that function we will see what are going to be our bounds for our x and how our x is going to behave corresponding to t when t belongs to the interval from -2 pi to 2 pi. And if we're going to plug in the t equal to 0, pi over 6, pi over 3, and just try to remember how the sine function looks like, then we're going to get something like this, that our sine function is going to be that green wave. And from there we can see that the bounds for our x are going to be that between -1 and 1. Or in other words, if we have the original Cartesian graph, then our parametric graph is going to be bounded between those two vertical lines. Next, what about y component? We know that our y component is equal to cosine squared t, and that cosine t is bounded between -1 and 1. But if we were going to find the cosine squared t, then since square is bigger or equal than 0, and since if you have cosine t is less than or equal than 1, and when you square 1 squared is still equal to 1, then our y is going to be bounded between 0 and 1. So in other words, we're going to have the corresponding bounds. The whole parametric graph is going to be within that rectangular. And right now the coolest part is actually to describe the movement of the particle. So what do we need to do? We just need to start by taking some points of t and trying to sketch our function. So first let's start when t is going to be equal to -2 pi. We know that sine at -2 pi is going to be equal to 0, as we can see on our green graph, or just remember that sine at multiply of 2 pi k is always 0. And our y is going to be equal to 1. And one thing, whenever cosine t is going to be equal to -1, since we have squared, it's always going to be equal to 1. So that's why we have our first. So we can see that we're going to start at the point which is given by intersection of our parabola with y-axis. Okay, let's take the second point, which is going to be -3 pi over 2. Then what is going to happen with our sine? Our sine is going to become 1 and our cosine is going to become 0. And since we go from t is equal to -2 pi to t is equal to -3 pi over 2, then we can see that we're going to move along our parabola down there. And then for the last point, when t is equal to -pi, I'm going to obtain the same point that I start with 0, 1. So in other words, when t is going to change between -2 pi and -pi, I'm going to go along parabola and come back. So the next thing, let's try to analyze what is going to happen when t is going to change between -pi and 0. And as you can assume, or you can check that what is going to happen, we're going to cover the other part of the parabola and come back. So in other words, the whole movement, if we have that part of the parabola, which is cut out by the rectangular, then we're going to start at 0, 1, move to the right, come back, move to the left, come back, and we're going to do that movement when our t changes between -2 pi and 0. But our t changes between -2 pi and 2 pi. So what is going to happen? We're going to repeat the same movement twice. And that is going to be the trajectory of our particle, which was described by that parametric equation. Okay guys, thank you for watching. If you're not subscribed to my channel, please subscribe, and let me know if you have any questions, and have a nice day. Bye.